Hi guys, in chapter 2.3, okay, we will be learning on exponential equations, and essentially the way to solve it, besides using our rules of law, or rather laws of indices, which you have seen in the previous chapter, we will also be learning a new strategy, which is by a substitution method. Okay, so before I move on, let me just introduce what is an exponential equation. So just take note that an exponential equation is an equation that contains a variable in the index. Okay, so in this case, as you can see, okay, this x and the n over here is known as our exponent. So let me just give you a numerical example. Let's say I have 5 power x equals to 5 square. Okay, then I can say that x is equals to 2. Okay, let's look at our first example. So for the chapter on exponential equations, it is important that you are very sure on your laws of indices. So if you are still unsure about indices, please review the previous video on indices. Okay, so over here, root 2 can be written as 2 power half, okay, and power 3x. 1 over 8 can be written as 1 over 2 to the power of 3. And so now over here, we will multiply the powers together. So I have 3x over 2 and 1 over 2 cubed, okay, is just 2 to the power of negative 3. So I can then say that 3x over 2 is equals to negative 3, okay, and subsequently I will get this, okay, x equals to negative 2. Just divide by 3 both sides. Okay, in the next example, which is slightly more difficult, I will want to change my 4x to some form, okay, that contains a power 2x. So 4 is actually 2 square, okay, and I'll leave 5 2x as it is, okay. So 2 square to the power of x is just 2 to the power of 2x, okay, and this is 5 to the power of 2x. Okay, so recall in our law of indices, recall that a to the power of m times b to the power of m is equals to ab to the power of m. Okay, so over here I'm going to use that law. So 2 times 5 to the power of 2x equals to 10. Okay, and we all know that 2 times 5 is just 10, and 10 is equivalent to writing 10 to the power of 1. Okay, so 2x equals to 1 and x is equals to half. Okay, move on. So in part C, what we want to do is to change every term you see here to a common base 3. Okay, so I'll leave this as such. 9 is 3 square, okay, and 3 square to the power of x plus 1. Okay, 27 is 3 to the power of 3, okay, times x. Okay, let me just simplify this now. So 3x squared equals to, okay, if I have a common base, and I'm pulling out a division, okay, the powers will subtract. So just in case you've forgotten, so a power m divided by a power n is just a power m minus n. Okay, your law of indices. So let me just expand it concurrently. So 2 times x is 2x, 2 times 1 is 2, okay, minus 3x. So simplifying this, I'll get this, okay, negative x plus 2, and I can conclude that x squared is equals to negative x plus 2. Shifting all the terms to the left hand side, I'll get this, and eventually I can factorize to obtain this. Okay, so I can conclude that x is negative 2 or positive 1. Okay, or positive 1. Okay, let's move on to example number 2. So example number 2 calls me to solve, okay, ask me to solve this pair of simultaneous equation. So what I'm going to do over here is to first and foremost change to a common base. So for the first equation, I'll have this. Okay, 9 is just 3 square to y, so I get 3 2y. 27 is 3 power 3. So on the left hand side, I am applying this law. Okay, so just in case you've forgotten, let me just write it out on the screen for you. Okay, so x minus 2y equals to 3 cubed. So x minus 2y is 3. Okay, so I have my new equation. Let me just call this equation number 1. Okay, and over here I'm going to change all the bases to base 2. Okay, so 4 is 2 square, 2x, 2 6y, and 1/4 is 1 over 2 square. Okay, so let me just simplify this further. So 2 times 2x will give me 4x. Okay, so in case you've forgotten, the rule that I'm using is this: a power n to the power of n is just amn. Okay, 2 6y. Okay, over here I'll change it to 2 power negative 2. And if I have a common base, the powers can add up. So 4x plus 6y equals to 2 power negative 2. And then I can conclude that 4x is plus 6y is just negative 2. And if I were to divide by 2 throughout, I will just get my 2x plus 3y equals to negative 1. And I'll conclude, and I'll call this equation number 2. Okay, so at this point in time, I have a pair of simultaneous equations. Okay, I think for this chapter, our main discussion is on exponential, so I will not be discussing how to solve this pair of simultaneous equations. Okay, but anyway, just for your information, the answer after you solve this pair of simultaneous equation is x equals 1 and y equals negative 1. If you wish to know how to solve this pair of simultaneous equations, please view the video on simultaneous equations. Okay, that's in chapter 1. Okay, last but not least, in the third example, we want to make use of this substitution, u equals to 3 to the power of x, to help us solve this equation. So the first thing I want to do is to express all my terms, okay, in a very clear way, such that I can see 3 to the power of x. Okay, so in the first term, okay, let me just do some side working. 3 power 2x is equivalent to 3x squared. Okay, so I'm going to replace this term over here with 3x squared. Okay, and the next term, you see over here. Okay, let me just do some side working to show you once more. So 3x plus 2 is just 3x plus 2. Okay, and I can write it like that. Okay, because for common base, the powers will add up. Okay, so this is how I break it down. So let me just write it over here for you. Okay, equals to 3x minus 9. Okay, at this point in time, I'm going to perform my substitution. So u is 3x, so this is u squared, minus 3 squared is just 9. Okay, and this is just u. So 9u equals to u minus 9. Okay, so I'm going to shift all the terms to the left hand side of the equation. So 9u minus u will give me negative 10u, okay, plus 9. Okay, and I can factorize this. So this is negative 9, negative 1. Okay, so I conclude that u is 9 or u is 1. Okay, so don't forget that we're not done yet, because what we're solving for is x, not u. So 3x is 1. And 9 can be expressed as 3 squared. So x is just 2. Okay, for the number 1 over here, let me just remind you of this very special law, that any number to the power of 0 is 1. Okay, so in this case, let me express 1 as 3 power 0. So x is just 0. Okay, so to conclude, x is either 2 or 0. Okay, that's all for the examples. Let me just summarize that an exponential equation is in the form, okay, that looks like this. And a strategy involved for solving exponential equations will be to substitute, okay, u equals to 2x to the power of x, okay, for example. Okay, let me just leave you with some practice questions. You can pause the video here and try this on your own. Okay, and thank you for watching. I'll see you in the next video.